So hello everyone again, nice to see you and welcome to another Saturday microscopy live stream. After a week break, I'm back again from the holidays and yeah, we'll do again a little bit of microscopy and sample preparation together today. Yeah, there are a couple of random things I just want to show you, and like every week, it's going to be a little bit improvised. So maybe I'm going to change the topics around based on your interests. In any case, I would like to say hello all around the world. I'm now not going to read all of the countries like I used to do in the past, but I'm going to jump in right away into a few things that I would like to show you today. After 2 weeks ago, there has been the live stream was a little bit embarrassing for me because some of the connections didn't work. The main microscope connection didn't work. I found out what the problem was. It was actually the USB cable came out from the back of the computer. That was it. Yeah, so that got sorted out quite quickly. And the other problem is that they had some other connection problems. So what I did is the following. I bought myself, for my small microscope, I bought myself, I have to get it out here, look, a USB camera, right? I would like to show that to you. And I'm going to not put it into my good microscope, but actually into a very cheap one. And so that's one of the things I want to do later. And what you see right now over there, these are some tiny, yeah, things that I collected a few years ago from a beach. They're tiny. And I want to mount them, but the problem is how you're going to mount, even though they're kind of small, they're still fairly thick. So I would like to show you today how to make those spacer rings. It's not the first time that I'm actually showing this to you, but today I found a new way of gluing them on a microscope slide. And by doing that, we can actually put sand into the space, on the slide here, and also maybe a couple of those tiny little seashells as well. Okay, yeah, so that's the thing. If you have any comments or questions, please feel free. I also, Christoph also sent me some pictures from really nice pictures of Drosophila fly using fluorescent microscopy. If you don't forget, I'm also going to show them to you. Yeah, and we're going to see where we're going to actually go from there. So I would like to, show you the following here. Let's go back to the stereo view. Those tiny seashells that you see over here, I would like to mount them, right? However, I think it's quite obvious that just putting them on a microscope slide with a mounting medium, it's not going to work. Okay. So what I would like to try to do is I'm going to choose the smaller ones here, and I would like to make a dry mounted microscope slide. Basically using those, and I'm going to get right away directly into it, and then I'm going to show you how I actually made those here. But I just would like to use this here as the first sample here, and I need to go maybe a little bit closer here. And what I have, I'm going to push them to the side, and I have to do now take my tweezers, and I'm going to now choose small ones from here, hoping that they're still not too big. But you know what? I'm going to pour them out here. I collected them a couple of years ago. I think it was, I visited Croatia for a summer holiday, and on the beach from the sand, I basically found them. And I have to now choose the smaller ones. I'm going to see which ones they are. Maybe this one over here. I'm going to put them in here, right? Maybe this one over here. And I deliberately do not want to glue them down, because every time when I shake them, I want to be able to see different parts. And I also would like to do this then later on with a sand sample. And I don't know, the bigger ones won't work. Maybe this one is also small enough. Yeah, I think so. 5 of them should be fine. Okay. And now a cover glass goes on top. Okay, so the question is now, how am I going to mount the cover glass? I'm first going to clean the cover glass, because I would like to show you then the new technique that I experimented with today. I'm going to use a little bit of I have to be careful that I don't, use a little bit of, a tiny amount, a few drops of, doesn't work, a few drops of alcohol, because I want to get the, all of the grease from my fingers. I want to get this off from the round cover glass. Okay. So, and now the hour of truth. I'm going to now show you the new way, new under quotation marks, how to glue this cover glass onto the spacer. And you can actually see already here that when I made the spacer, maybe I'm going to take another one here. When I made the spacer, it's a little bit blurry. You can actually see that I don't know if the camera is able to focus that closely. Here it is. Right, here we go. Yeah, when I made the spacer, let's put this down here. Yeah, which I 3D printed. And by the way, in the description, I put a link to the STL file in case you also want to print those. You can actually see that this is a little bit lower than the rim here, so that the cover glass rests inside here, right? So this is kind of the idea. Yeah, I'm going to occasionally also read a little bit the comments here, and what I'm going to do is I want to glue now the cover slip in here. And in the past, I always used clear or nail polish, right, which contains a solvent. This kind of worked because the solvent, acetone or whatever is in there, also dissolved a little bit the plastic from the 3D print. However, it also started to shrink a lot, and sometimes the connection was not quite solid. But I think I found now a very good glue, under quotation marks, to actually glue it in here. And I would like to show that to you. And that is this one over here. It is not nail polish, it's nail gel, and it's UV curable. So what I do is this is a very thick thing here. It's not suitable as a mounting medium because it's so thick. But what I can do is I've got an ultraviolet lamp here, flashlight over here. It's a UV flashlight, and it's able to cure it. So what I would like to try now is the following. I'm going to make this a little bit higher again. Okay. And I would like to carefully, and that's maybe the good thing about this, is that there is no hurry right now because there is no solvent to evaporate. I'm going to just, cover the side over here. It doesn't even have to be everywhere. It's still very thick, very thick and stringy. So let's do it like this. Not too much. Not too much. And we can take our time because it does not dry. It basically, you need ultraviolet light to cure it. So you probably do not want to do this in bright sunlight, right? And then what I do is the following. I'm just going to drop the cover glass on top here, right into here. You can only see this. And by moving it, I try to make it lock in place. Okay, here we go. Okay. So I think that's gonna be fine. And then I'm going to use the flashlight, the ultraviolet flashlight, and I'll give it maybe 30 seconds or so. And it actually turns hard. It's really a miracle thing. It turns solid fairly quickly. And then it should be okay. And what I probably would do then, I'm not going to do that now, but I have got also a slide ringing table. Maybe you can actually seal it off even better. Yeah. But what I have here is this is a so-called a dry mounted microscope slide. And even if I don't know, you can also try it from the other side. Okay. And actually, if you touch it, it's actually now quite solid. Yeah. Now, of course, the object is able to float around. Yeah. Maybe that's a little bit of a problem. It sticks a little bit to the side, but I can actually, let's try to see it here under the stereo microscope. Yeah. And we can actually zoom in much more. And I would like to try this not only with those seashells, but also with sand samples. Yeah. And then by shaking it, you can actually, also, of course, then also look at the different parts here. Yeah. Yeah. So this is a little bit of a thing that I've been experimenting around with. Here's another one. Yeah, it's got to cure completely because otherwise it remains a little bit sticky. Yeah. Yeah. But I would like to now show you how I've actually connected one of those rings now to a slide, and I need a piece of paper for that. Okay. So occasionally, if I'm pausing, I'm just reading the comments a little bit. Yeah. Because sometimes if you have a question for me, then you can actually, yeah, I've seen there's already a question for me. Because, okay, just a second. Off topic, future live stream idea, live sample collection day in the field. Then the next week stream, we look at the collected sample. This would be actually a nice one. Thank you for the recommendation. Of course, I would have to pre-record this. Basically, when I'm out in the field, there's some ponds in the area. Yeah, and I can do that. Because the refraction index, why don't you use oil as a mounting medium? Let's put it this way. You can use oil as a mounting medium, of course. And indeed, sometimes it's useful. However, it does not solidify. So it's actually a temporary mount. But oil, immersion oil, for example, can be used. Some people also use glycerin, pure glycerin, or glycerol rather, as a mounting medium, and this also works. Depends really on the sample that you would like to look at. So what I'm doing right now is I just want to find the center of the slide. So I'm just doing it like this. Yeah, this is just basically as a little yeah, orientation help, and I make an X here in the center. Yeah. So I know a little bit better, or so that I'm able to estimate where to put the ring. Okay, so I grab myself one of those spacer rings. Okay, which looks like this. So what I just want to show this to you as well a little bit. It's a slightly more than a millimeter in height, and you're able to put an 18 millimeter cover glass in here, right? Yeah, and it kind of yeah, locks in place. But of course you have to glue it, and then on the side you can of course add another ring. Yeah. So what I'm going to do, however, first is I have to now add a little bit of this UV curing, and you really wanted to use very little of this. The first trial, this was my first trial. You see how much it was way too much that I've used. Yeah. So you need a very thin layer. And the good thing is because it does not shrink when it cures. Yeah, it basically stays. It makes a good contact, because I've tried this with nail polish, and then after it started to dry, during the drying process, it shrunk so much that it actually lost contact with the glass slide. So that's already more than enough. So what I have to do now is yeah, I guess I gotta rotate this now here like this. Yeah. This is probably already too much anyway. Yeah. Doesn't, yeah, here you see it. Okay. I turn it around. And I try to place it more or less in the center here. I press down. Yeah, it's okay. A little bit spilled out, but not too much. You can see that it's yeah, still moving. On the other side, looks like this. You see that it makes, I don't see any bubbles in here, so it makes very good contact. Yeah. And now I have to close this and I have to remove this. I don't want to have any ultraviolet light here. And now I'm just going to basically, yeah, shine for a couple of seconds the ultraviolet light on here, and of course also on the other side here. Yeah. This is a UV flashlight. I don't know if you're able to see this. Well, the light looks very almost white, but when I look at it, it looks blue in color. Yeah. So I can use this, yeah, the spacer rings are 3D printed. Yeah. And basically, what you can also try to do, and I've also tried it, I used, you can try to punch out these things from a, let's say, old credit card or something like that. Yeah. So I've tried it also with cardboard, of course. I had problems gluing the cardboard to the slide because the cardboard would actually absorb so much of the glue that there wasn't any contact made. So maybe this UV gel, maybe this actually would also work with cardboard. Yeah. So I don't know. I guess what I probably would do afterwards is I would probably put it into the sun with a more ultraviolet light. But you see, I just want to show you, yeah, it's solid right now. Okay, it doesn't move anymore. And I just want to demonstrate this on this here, which I made today in the afternoon. I just want to show you how hard it actually becomes. I need a scalpel. Here it is, a sharp knife. Yeah, yeah, because it's yeah. And look, you can actually, yeah, try to, yeah. You can see how extremely hard it becomes. Yeah. So just kind of I better be careful that I don't cut myself, right? Yeah. But this yeah, this is quite surprising. Now, what I actually also realized is when you put a UV light on it, it actually starts to warm up a little bit. So I suppose there's some kind of an exothermic reaction happening. Okay. So, and what I would like to do now is I have here a small sand sample. Why so small? Because I visited a place, and generally I don't recommend taking sand samples, but this one was from a beach where we were swimming. And I did not collect it, but I actually found it inside my, yeah, inside the shoes and inside the tent and so on. So I said it before, yeah. So I accidentally took it along. So you have to be careful because in some countries they don't like it if you take along stuff, yeah, from the beach. But this was just a regular beach and it was not from a protected area. Okay, so yeah, that's of course that's of course a little bit of a problem because yeah, you have to make sure that there is I don't know if this is actually maybe a little brush would have helped because where you've got the cover glass, you don't want to have any of this sand, obviously. And another question that I have is maybe some of those particles are a little bit too big. I'm a little bit worried about the larger ones here. I want to play it safe and maybe take it away. Otherwise, I might not be able to put the cover glass on here. Yeah. So, and I'm going to now do a little test on whether the cover glass would actually drop in place. No problem. No problem. Okay. So now I won't get it off again. Okay. I'm going to quickly clean it again with a little bit of alcohol to get my fingerprints off. Okay. And again, I'm going to apply a little bit of this, this nail gel. When I bought this, it wasn't so cheap. I was a little bit disappointed because I found it was way too thick to be used as a mounting medium. So I actually didn't have any use for it at all. But then I realized all of a sudden that actually it can be used also as a glue. Yeah. You always want to add the sand first. Otherwise, if you apply this the nail gel first, then of course the sand grains are going to stick in the nail gel, which you don't want either. Okay, patience is always important. Of course, during a live stream like this, I'm not quite as patient as one probably should be. Yeah. So I think that's enough. I'm going to now close it again. I'm going to take the cover glass and drop it onto the here. And yes, it locks again into place. Good. Oh, no, I moved it away. I think that should be okay. Yep, and ultraviolet light for curing it. And yeah, 1:20 a.m. Yes, some people are staying up late. Yeah. Uh, Yes, just for your info, it's correct. All of those live streams are recorded, okay? So you don't have to stay up late. It's gonna be available online. Yeah, you can watch it always later. As a matter of fact, most people watch the live streams later as a regular video. Yeah, and what I'm also going to do is I also plan to make shorter versions of this video, where I just quickly give a demonstration of how this actually works. Yeah, because watching a 1 hour live stream sometimes is a little bit too long, and sometimes these things can actually be shown quite quickly. Yeah. So yeah, I know you got to be careful. There was a case somewhere where an entire beach was stolen overnight. No, I know that in some protected areas they're really strict, and I think rightly so. Okay, so and that's basically means that it has cured again. Yeah, and actually it has become solid. Yeah, and now we can have a look at this sand as well under the stereo microscope. So where's the stereoscope? Let's always go down with the magnification first. And then sometimes there are a couple of surprises that you're able to find. Yeah, maybe some, yeah. So some tiny seashells, some microplastics maybe. In recent years, when I checked it, I also found small pieces of glass even. Okay. Because of yeah, glass bottles and so on. Oh, and then look, I don't know what I don't know what this is. I have to focus. Oh, this is an interesting one. Could this also be some kind of a this one right in the center here? So I don't know. It's also some kind of a eroded shell or snail or something like that. I don't know. Yeah, I mean you get the idea. Yeah. Maybe I should have added a little bit more sand, but I didn't have more. So in any case, I have made already in the past a whole range of these sand slides, but yeah. And you can see that especially for stereo micro, and then you kind of shake it again a little bit, and then you can see, you see here on the side now it started to glue to the side. Maybe it was not completely cured yet. So maybe it would be a good idea to, yeah, simply give it maybe a couple of more minutes in the sun in ultraviolet light to completely cure it. Yeah. Yeah. So, yeah. I'm just reading the comments. Yeah. Yeah, I know in Italy, I know people have been already fined, but some people have actually been, how do you say, really taking along large amounts of sand samples. Yeah? Not a good idea. Yeah? And yeah, so what I would like to do next is the following. I would like to, like 10 to 15 minutes. Yeah. Yeah, exactly. That's what I would like to do anyway. That's why I made so many of them. I would actually prepare all of the slides first, and then probably cure them using regular sunlight for several minutes. Yeah? But I mean, this is just a short demonstration that this actually also kind of works. What else do I want to do? I'm going to now show you a very short video. And then I would like to crystallize some salt, maybe also here. We're gonna see how this actually works. I would like to, and maybe I should, you know what, I'm just gonna show you the video first, okay? Very quickly, and I'm going to comment on the video. Where did I put the video here? Yeah, this is a on a beach on the Canary Islands. I was there last week. Okay, and look at this plant here. There's a reason why I show it to you. This is all volcanic rock. Yeah, so it was quite already in the evening, and there were some patches of water there. Yeah, waves in the background. Fuerteventura, I visited, and family trip, and it's already quite in the evening. So far, nothing unusual. But look what I found here. Look what I found here. This white stuff. What is this? I thought, wow, this looks like ice. Yeah, that's like ice. No, it's not ice. It's salt, because of course the seawater evaporated, and yeah, there was salt there. Yeah, it's quite surprising. I did not expect that. Yeah, so believe it or not, what did I do? Of course, I said that is not sand. Nobody is going to complain about me taking a little bit of sea salt along. Yeah, so this is basically what I did, and indeed, I collected a little bit of sea salt. Yeah, from there, I've got it here. Okay, here it is. Yeah. And we're gonna put this also under the microscope. Yeah, I'll quickly here. Yeah, so, okay, the video will quickly interrupted. And it was actually quite interesting. Yeah, it was pretty crystalline, as you can see, and I had to really loosen it up to be able to pick out some of them. Let's move. Yeah, here it is. I mean, you get the idea. Yeah, small sample. Yeah, and I said, yeah, this is actually something where we can put some sea salt under the microscope. This one is not going to look very interesting as is, but maybe if I recrystallize it with a little bit of water, then maybe we're able to get some nice shapes. We're going to see. However, there is another thing I wanted to see because a few days later, this is the place that we visited. This is actually, yeah, this is how they actually harvest salt. Yeah, so these are evaporation pools. And so it's for commercial salt manufacture. And there was also a whole pile of salt there that they discarded because it got dirty. Yeah. So this is all pure sea salt. And here we start again. And the reason why I wanted to show you this plant is because it kind of shows you how salt tolerant this plant is. And of course, believe it or not, of course, I brought along, where is the desk here? Yeah, I bought it in the shop. Yeah, they basically also sold the salt here as well. Okay, so that's basically that's how it looks like. Focusing. Yeah. So, and I decided why not put a little bit of this sea salt also under the microscope. But the problem is how do you make a permanently mounted slide for that? Because I'd have to put some, because sometimes the crystals are not flat, right? So I decided, well, maybe this will also be an option. Kind of using those spacer rings here and actually crystallizing it inside here, and then putting a cover glass on top. So this is a little bit, I did not try that, okay? So in that sense, it is also now something new that I'm trying. So we do the same thing as before. And again, yeah, salt crystals under the microscope, yes. Yeah, they actually look quite nice, especially during the crystallization process. But of course, I want to preserve them as well, at least. Yeah. So let's do this very quickly. Let's do this very quickly. Okay. I'm going to turn it now here like this. So again, I'm doing this extremely fast just for the sake of this live stream, but of course in real life you probably want to take more time. Look, this is a little too much already, okay? Yeah, you see how it kind of oozes out. I could remove that later. So let's do the following. Again, a little bit of UV light here. This is a little, maybe you've already seen those concave slides, those slides that have an indentation. Yeah, if you want to observe larger specimens, I mean, maybe this is also kind of a workaround here, right? Of course, on the other side as well. It could, of course, be that the glass also absorbs a little bit of the ultraviolet light. Yeah, this is quite possible. Let's give it a couple of more seconds. Um, yeah, I was thinking the spacer and the cover glass would protect the crystals. Yes, as a matter of fact, that's actually what I would like to do. Yeah, because I would like to crystallize or try to crystallize it on the slide, and then add a cover glass over it for protection. Yeah. So. So, okay, let's just assume that it's finished. It is indeed solid already. Okay. Again, it's or semi-solid. Yes, it would probably need more. I'm just going to leave it as it is. I need a small dish, or I don't know, or maybe not. You know what I'm gonna try? I'm just going to, yeah, I need a small dish. I'm going to simply add some tap water. Actually, probably distilled water would be better. But we're just going to do it like this. I need a pipette. And I'm going to simply add a little bit of this in here. I mean, theoretically, I could add it all the way to the... I could add more, theoretically. Why not? So that's one, maybe, oh, yeah. Well, I'll just give it a try. And now, where is my salt? I lost it. Here, oh, here it is. I'm going to take a little amount of this here using... No, this is not. These are not good tweezers because I cannot go in with them. I'm going to do it the easy way. Ah, here's already one. Why not? Why not try this here? Put it in here. Dissolve it. I don't know if it's already in saturation or not. And no, it's still continuing to dissolve. A few crystals don't hurt. I mean, they will add as crystallization seeds. So maybe it's enough. I don't know. So yeah. If it stops dissolving, then it means that the salt solution is saturated. I mean, we could say it's enough. And close this again. And yeah, I'm just going to now put it directly under my compound microscope. Let's remove the thing here. Let's remove the arrow as well, which we have to close the condenser. Here we go. And lots of impurities, obviously. Yeah, I mean, this is sea salt collected directly from the beach, so it's bound to be a little bit dirty. And what I hope now is as it evaporates, and maybe we're going to speed this up a little bit, that we see some of the crystals forming. Okay, so and in order to speed it up, you have guessed correctly. Look what I've got here. The desk. This is again the coffee warmer. This is now a little bit a test of the whole system because I wonder how temperature sensitive this is or not. So I put it on here. Oh, there's 80. And as it, you know what? I could actually do the following. I'm going to give this crystal back in here. Maybe because of the heat or the warmth, it will dissolve a little bit more. Okay. It's quite warm already. So let's have a look. If maybe after a couple of minutes, the crystals will start to form. Maybe I did use a little bit, a lot. You can, the liquid will already starts to disappear a little bit. It's patience is required. Yeah. A dilution series, yes. And I will have a look here. Yeah. So yeah, the liquid actually does decrease. I would like to, yeah, you have to be careful, of course, because the plastic might also melt, but 80 degrees should be fine. Yep, I see that there are already a few crystals forming here on the side. This is actually why, by the way, this is also a possibility maybe for a so-called a micro aquarium. Yeah. Yep, exactly. It won't melt it. It's usually at around 200 or so. But I'm going, because I see that crystals already start forming, I'm going to put it away now already. Allow it to cool a little bit, and maybe we can continue to observe this under the microscope. And of course, as it cools, then crystallization might continue because um, um, colder solution is not able to carry as much salt. Yeah, it's still quite hot. So I need to maybe put it on a colder surface. Let's put it this way. I'm going to put it on a couple of other slides here, simply to cool it down a little bit. Okay, here it is. Look how, yeah, how many. Yeah, I think that's gonna work. So over here, under the microscope, and here we go. Look at this, and you see already that. You know what? Let's do it like this. Yeah, and we should actually see that those crystals should actually slowly start to grow, and we can actually see that. Yeah. And so the cooling, as it cools, obviously evaporation also goes down. However, if it's of a lower temperature, it's also not able to hold as much salt. Yeah. Yeah, so still a lot of liquid present here. Let's see those tiny crystals over here. Oh, yep. Okay, now I basically have to wait until the water evaporates, but I'm going to speed it up yet more. I'm going to put it quickly back again on the hot plate. Yeah, maybe I did use a little bit too much liquid. Let's do the following. Because I'm going to simply remove some of this. Let's see how this looks like. Yep. Here we go. I think it kind of looks pretty. Okay. A little bit less light. Yeah. And when everything basically has evaporated, which is now going to be the case, then I can actually add a cover glass over the whole thing. Ah, there are tiny little crystals here as well. Let's see if they're still growing or if everything is already dry. Oh, did you actually see that? This actually fogged. I think this fogged a little bit the objective because it was still warm, maybe. Yep. Yeah. Yes, this is a comment here. Everything matters: solvent, temperature, air, humidity, the speed, everything. Yeah. So, and what I'm going to do now is because I would like to preserve this pattern, I would just want to make sure it's kind of reasonably dry. So I'm going to quickly dry it completely. Okay. Oh, you can see that. I forgot. Yeah. Looks pretty, looks fairly dry as of now. And this means that I would like to now also add a cover glass, just like I've done before. And then I'm going to quickly show you the other camera that I've got, a new one. And just as before, I'm taking a round cover glass, which happens to be dirty. I need again a little bit of alcohol. Here we go. I need a good place to put it, and yet again. I mean, these are all ideas that I'm having. I'm not saying that this is always the best method. So one of the reasons I'm doing this live stream is also to kind of simply test new methods and encourage you to try it out yourself. And then very often it's the case that other people have much better solutions here. So here we go. Oop, maybe a little too much. And this one goes on top again. Press down. Yes, there's now good contact. And again, a little bit of ultraviolet light. And we've got our permanent slide. Yeah. And we've got our permanent slide of salt crystals. Or at least semi-permanent. Yeah. Actually, I can also try to put it now also a little bit under the stereo microscope. So let's just say it's enough. Let's have a look under the stereo microscope. So, and here it is. Yeah. I think under the compound microscope it does look a little bit nicer. Yeah, obviously. So let's try it here again. Here we go. Maybe a lower magnification. Yeah. Could I try dark field? I don't know. Does this work? Like this? Ah, that's dark field. Yeah. Actually, also quite nice. Yeah. In any case, plenty of things to experiment. Yeah. The thing is the following. The question is how dangerous is this UV light? I would not hold it into the eyes, right? But then again, I mean, this is a UV LED, right? So please not into the eyes. But I do assume, I did not measure it, but I do assume that it's not extremely strong, because what they do is they also have those UV devices for people who put UV nail polish on them. You actually put your whole fingers into this device and get it irradiated with UV light to cure it. So these things are actually used also for that purpose. But UV light and eyes, of course, are always something. Yeah. Phase contrast is not going to work. No, this is not phase contrast. This is dark field. Phase contrast, unfortunately, I'm not able to do, and the reason is because the distance, it's too tall, and there is not enough distance, and I only have a 40 times phase contrast objective, so I wouldn't be able to show it to you. It's the objective would actually crash into the thing here. Yeah. So the question is, what's the purpose of sealing with glue? The purpose, very briefly, is the following: is to let me show this to you here. Is that for those of you who joined late, I want to have certain specimens that are mounted in air where I cannot add a mounting medium, and I want to have this somewhat protected a little bit. I mean, this is not for all eternity, but if I want to have those salt crystals on the slide, then I mean they're gonna fall off, or if you touch it, then they're gonna rub off, right? And by having something like this, at least it's I have a permanently mounted slide, and I cannot add mounting medium on this because it's too thick. So this is basically one possibility, especially if you also want to use it for stereo microscopy. Again, not suitable for all slides, but for all specimens. But at least that's an additional option that there is. Yeah. So, what else do I want? Yes, I'm going to now show you very quickly, because Christoph sent me a couple of very nice pictures, and he gave me the permission to share them with you. And I don't know if he joined now here as well. But he sent me some pictures. I would like to show them to you. And this is using ultraviolet light, and he put some Drosophila, which is a fly. Yeah. Under the it's a little bit too fast, the slideshow. So maybe I'm just going to So these are the compound eye of I'm going to So where's the next one? So this is quite nice. So also using stains, and I kind of like this as well because it looks very pretty, especially this one here, right? So that's the head of a fly, and also blue dots that you see. These are basically the simple the eyes, the so-called the ommatidia of the compound eye of the fly. So using fluorescent, and he has all of the technical details. He's written it into the corner. So I would like to say thank you very much. I don't know if he's joined the chat today. This here, for example, is the trunk, where basically the fly sucks the food. Let me show it to you. Just a second. I need to move the arrow all the way to the top. So that's the head part, and that's kind of the trunk. And it's basically the where it actually starts to suck up the food. So 500 micrometers. So that's half a millimeter. So it's So it's really, really nice. Let me show where is the next one here. Here. Also so using fluorescent dyes, of course. It's really nice. So thank you very much. Look at this here. I mean, it's it is at low magnification. So so this is kind of really pretty. So this one here as well. So thank you very much again for sharing these these pictures. And then we're starting again from the beginning. So it's really cool. I'm reading again a little bit here. Some of the questions which you're already answering among yourself anyway. The bigger shells were a problem for his microscope. Yeah, Yes, I get it. I get it. At the very beginning, yes. So this is one of the comments here. Thank you for clarifying. I picked out the smaller ones. I just want to show this to you because this was a little bit not clear. So basically, what I have done for making, where did I put it? For making this mount here. Yeah, I picked out the smaller ones because the larger ones would have been too big, and I would not have been able to put the cover glass on top. Yeah, that's the reason why I selected the smaller ones. So just to make sure that the cover glass would actually fit. Otherwise, I would not have contacted the spacer. That's the only reason. Yeah, that's the only reason. Yeah? So I'm going to put this here again away, and I would like to now. What time is it? Okay. I would like to now move on a little bit, and because not last week's, 2 weeks ago, the the live stream was a little bit a frustration for me because of some technical issues, and so I said, this can't be, because I wanted to make actually a live stream and to talk a little bit about cheap microscopes. And I decided what I will do is I'm going to make a completely separate video of this, which you can watch in any case, and also a video of some microscope cameras. So I would like to show you what I have bought, and I would like to, again, put the standard onion and some other slides maybe under the microscope. And this is basically this is my cheap, introductory microscope. How much? Around 100 euros maybe. And over here I've bought myself an eyepiece camera because I tried it with a mobile phone and this was horrible, right? If you remember, right? So I decided, forget about it. I'm gonna get myself an eyepiece camera. This one was around only 70 euros. And I would like to simply test this with you. I'm just gonna show it to you first. Okay. I guess it's sold also with under different brands, but there is a reduction optic in here, right, which actually gives it a wider field of view, and it's directly connected to USB-C. And what I will do as a little how do you say this, little trailer, I'm planning right now to do a more comprehensive video where I'm going to actually show you several of these eyepiece cameras, because I've got I don't know how many of them, 5, 6 of them. Right, and they're not all the same. Each one has its own problems and advantages. Yeah, and I just want to show this to you then. So what I'm going to do now is I'm going to put it back in here. I'm going to now do the following. Let's see if I'm able to get here. This is now the view of and I'm going to switch it on. And I'm just going to show you a standard slide. Yeah. Just to show it to you, and then I'm going to, and this is how it looks like. Using this cheap microscope 4 times, 10 times, right? Maybe a little bit more light. And now with the 40 times, which should be actually the lowest quality one. And indeed, it is a little bit blurry, but it's not a camera problem. So but still, I think honestly, those tiny microscopes are not very convenient to use all the time, I admit. But for the low cost, I see there's already a little bit of dirt here. It's okay, especially if you go then into Photoshop and do a little bit of editing. Yeah, I'm just reading here. It was frustrating for you, but it came across as especially lively. So actually kind of a delight. Yeah. The maximum frame per second. Yes, I can tell you the following. I measured it. It's around 16 frames per second. Not very much. That's actually one of the disadvantages of this camera. And this is actually one of the things that I would like to talk about in a separate video that I'm now preparing, which is going to be just about it's going to be a slightly more organized video. I thought about maybe doing it in a live stream, but then changing the cameras around all the time, it is a little too difficult and it's confusing. So I actually want to make a completely separate video just comparing those eyepiece cameras. Yeah. These are very low frame per second, but if you're interested in video, you won't believe it. If you really want to have high frames per second, and that's also what I'm going to show in the video, is actually then you would have a system, this homebrew solution with an HDMI connection and then an HDMI to USB connector. And with that, I'm actually getting 30 frames per second. Yeah. So you see, it's kind of a workaround. Yeah. I'm also going to talk about that. Yeah. So that's yeah, it's gonna be a technical video that I'm gonna make. I thought about should I do this in this live stream or not, but then I decided nah, it's too complicated. Then it's gonna be messy again, and yeah, plugging around the and then connectors. So what I would like to do now is I would like to repeat now this experiment that I did with the mobile phone, and I would like to see if there is the possibility. Let me look at this. This is already a little bit dirty. Let me see if I would like to see if it is possible. And I'm going to put the microscope now over to the other side now that you've seen it. We don't need it anymore. And I'm just gonna do this standard test specimen, which is the onion. Because it's for me this is always the go-to. I know you're getting bored already by it because it's always the same specimens. Look, it's pretty dried up already. Before I throw it away into the trash, I do a because it's a nice reference. It's a nice reference. Let's see if I actually here it is. Is it or is it not? I have to find the onion skin first. As always, patience needed. Nope, 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 nope. Let's try this here. It's actually surprisingly difficult. Maybe because the onion is not as fresh anymore as I hoped it to be. But here it is. Here it is. I found some. Here it is. That's the onion skin. Goes on here. Flat. Completely. It's a little bit folded. It's folded. You know what? This will damage it a little bit, but who cares? As long as it's kind of flat. Cover glass goes on top. That's usually the way I do it. I first put on the cover glass before I add the. This contains now the salt. Still goes away. And I need a little bit of water. I forgot where I put the water. Here is some water. Did I put this? No, the salt was over here. This is just regular water. So, just allowing the, yep. And any excess on the top I want to remove. So, yeah, that's the standard onion slide. Let's have a look now under the, yeah, I almost wanted to say kids microscope, but these things are actually also suitable as field microscopes maybe. Here. So that's this. Yeah. Let's go up. And I have to tell you, here we go. A little bit more light. Yep. Maybe there's a better point. Yeah. So you see that there's still some water flowing over it. But what I want to show you, and maybe there, I don't know, I have to see if there is a better place where we can actually find that. Let me find another location here. There's not so much movement going on, maybe because the onion is already a little bit dry. But I should just show this to you here. Where's the arrow? Of course, that's of course the nucleus, the nucleolus inside here. And sometimes you see tiny dots moving around in the cytoplasm of the cell, and these are vesicles. So this is basically, for me, this is a little bit also a quality test. Am I able to see those tiny vesicles inside an onion cell? Yeah. And this that kind of shows that, yeah, even those cheap microscopes are these days, if you've got a proper setup, actually, at least for their money, surprisingly good. Yeah. Yeah. So what I'm going to do now is just as a comparison. Yeah. So this is now the 40 times, and let's remember a little bit how big the picture is. And I would like to show you now in comparison how this would look like in bright field using my huge microscope. Okay. So I'm going to also do that here right now. I have to move this away. Let's go directly into the 40 times. And this is now the image, yeah, how it looks like through my big microscopes, also bright field. I mean, yeah, it is a little bit more clear. I mean, it better be, right? I mean, we're talking here about very cheap objectives and here very expensive ones. But honestly, yeah, considering this huge price difference, yeah, those small microscopes also get you quite far. Yeah. So let me quickly read some of the questions here because you're discussing something that I did not quite follow. Yeah. Yeah. Yeah, if you want to take a photo or video, phone works fine for sure, though it's still a pain to set up. A mobile phone works. Okay. It's not as convenient because because even if you have a mobile phone adapter, you really have to carefully align it, and it's very shaky. Huh? But generally, the quality is fine also with a mobile phone. Huh? Yeah, a few of them in good spots. Yes, I'll just read here a little bit. Uh, I was wondering why not put a container with all big shells directly under the microscope. I thought there was a limitation somewhere. I have actually done that. The container put it directly, but let's put it this way. I've got a collection of different slides with sand samples and tiny shells, and it's simply easier for having a larger collection. Yeah, that's the only reason here. Yeah. So, yeah, time lapse recording. Yeah. So yeah, so that's basically how this looks like. I'm going to go back again now to the to the other one over here. To the where is this one? This one over here again. Yeah. And I just want to show you. Yeah. Oh yeah. One a disadvantage of those cheap microscopes is, and you see this primarily when you actually zoom in, is there is some chromatic aberration, which basically degrades the image quality a little bit. Yeah, but otherwise, yeah. Let's maybe turn it down a little bit here. Yeah, yeah. So this is kind of a little bit too. Yeah, that's a huge air bubble already. Here we go. Here we go again. Yeah. we're back to that what we're able to see, what we had before. Yeah. So I'm just reading a couple of the comments again. Yeah. Let me quickly turn around and show you something. Do I have it here? Just give me 10 seconds. I know this is gonna be one of the more crazier projects that I have dug up. Okay, I just want to show this to you. I'm gonna try to reactivate this, and maybe this is also gonna be the topic of a video or of a live stream. I already made some videos this year. I made this one here, for example, a couple of years ago. It's actually a functional Lego microscope. So I put over here, down here, I put a microscope objective. Up here, this here is a you can put an eyepiece in here at the top, so that's from an old film container. You can also put the camera in here. And how do you focus the thing? You can focus this thing by moving this part in and out. So not by changing the distance here, between of the stage, even though this is also a possibility. So I'm still working on a mechanism to focus this here, but it's also possible to focus it by moving this in. It actually works. And then you put a little lamp on the bottom. Yeah, it actually gives you a totally normal picture. As well, yeah. And how did I connect it down here? I just want to show this to you because this is. I'm going to take it apart. So what I've done is the following. Here, this is plywood. Yeah, and this one over here is simply nothing more than the plastic cap of one of those containers where you store microscope objectives, and I just drilled a hole into it. Yeah. And I glued it on here, and that's it. Yeah. So yeah, I'm going to working also on a video on this. Just wanted to give another preview. I just have to get it up and working again and add a lamp, and then we can also do some fun stuff with that. I'll put that away. Yeah, this was not the the Lego microscope. Yeah, I actually also have the fold scope, but I'm not able to put a camera in front of that. Yeah. Yeah. So so this so basically, I made also a video on the fold scope, but this is a separate video. So what I'm gonna do now is very quickly this is an important comment here. Clear difference between the lower cost scope views and the Superb Olympus views, but the budget friendly scope still. Yeah, honestly, what I think, I mean, that's my opinion a little bit. Different people have different opinions on that issue. The question is how much should you spend on a microscope, right? And the idea is, I mean, my opinion is some people send me emails and write comments, and they're over analyzing the whole thing, right? And they don't make a decision. And my suggestion is just don't think too much. Get yourself a cheap €100 microscope first. Play around with it a little bit and gain the first experience and learn a little bit, and then later on you know better what you actually want to have. This is my very pragmatic approach. Those cheap microscopes are not great, obviously not, right? They're more difficult to look through with only one eye, and it's difficult to move the slide around. It has no mechanical stage, but they're good for that price, right? They're fun to use, and actually I also use them occasionally as a travel microscope or whatever. Yeah. So so this is I think that's a little bit my philosophy. One should not, I mean, different people define the hobby differently, obviously, but I think it should not all just be only about the hardware, but actually also what you're actually able to do with it. And as I said already before, I mean, the scientists back in the day, I mean, look at their early equipment that they had, and some of them really made important discoveries. Yeah, with fairly simple devices. Yeah, so yeah. Yeah. There's this so to say this how do you say this 80-20 rule, which basically says that with 20% of the cost, you can see 80% of the things. And then if you really want to get the last detail, then the prices go up very, very steeply. Yeah. Yeah, so that's what about this whole thing? AI upscaling? What is that? Uh, is this about the upscaling of images using AI? Yeah, I don't know. Upscaler AI software for photo or video. Yes, that's another uh, that's another hot topic. The use of AI. Yeah. So what am I gonna do now? Is I'm going to I think, you know what? Just for the last 5 minutes, and I'm gonna call it quits. I'm just gonna show this to you as well. I just also found this. Maybe some of you already know what this is because I already talked about it in the past. But this is actually also one of the things where I was thinking maybe I could put it on a slide. Let's see where it is. Where is it? Where is it? Where is it? Here it is. This one here. Yeah. Those tiny things here, these are the spines of sea urchins, right? Yeah. So this is yeah, also something that right now in the container, yeah, but also something where I was thinking maybe I could put it on on a microscope slide for easier storage. Yeah. ART video enhancer. I see. Yeah. See. Yes. These are sea urchin spines. I picked them out of the sand as well. Yeah. Look very pretty. And typical specimens for stereo microscopy only because they're too dark. You cannot use them under the compound microscope. So this would actually also be one of those specimens where I could put them, yeah, with those spacer slides. Yeah. Comment here, I'm jealous. Or really, I looked everywhere online and couldn't find these pretty spines to buy. All the ones that being, these spines, I basically painstakingly, I mean, this is when I visited Croatia a few years ago. There's so many sea urchins there, you cannot believe it. Yeah, and the sand there is full of these spines. Yeah, and they look extremely pretty. And this is something that I already also talked about, but I don't know how to do that. They look in cross section, but you have to actually grind them down and polish them down, right? Some have to mount them in a resin, maybe in some epoxy, whatever, and then you have to kind of grind them down and glue them on a microscope slide. It must be extremely difficult to do. But that's actually, yeah, also something that I've got a little bit on my agenda, but I need to do a little bit more research on how to do that. Yeah. Have you ever used a water immersion lens, the dipping kind? I know what. Yeah, I've not. No, I've. Okay, I've never used a water immersion lens. And water immersion lenses can be directly dipped into liquid. I know that some water immersion lenses are used in cell culture, so where the people are growing actually cells in a petri dish. I've never tried this myself, right? I just hearsay, right? So what they do is the following: desk view. You have a petri dish, and it's like this, that plastic petri dish, and you have the cells growing on the surface of the petri dish. And then you have those water immersion objectives, which are basically directly rotated into the liquid for observation, right? Never used them before. I know I've seen somewhere online one company that actually sold an objective that can be used both for water immersion and oil immersion. Okay, but I've never used this before. Yeah. Yeah. Okay. You're talking about the sea urchin things here. Okay. Used water immersion lenses. They look like they're made from the same stuff as pearls. Yeah. Okay. Here it is. Yeah, it's actually, I think it's made of calcium carbonate. So they should be actually quite acid sensitive. So if you add some acid, they should dissolve. They remind me a little bit like those pillars in some old buildings, Yeah, this kind of, yeah, those Roman or Greek, I don't know, pillars that they have from the antique times. This is a little bit how they look like. Yeah. Okay. I found a used DSLR camera purchased from a reputable camera dealer for $125 works better than a $800 dedicated microscope camera. The good news, not the advantage of DSLR cameras is that they have a huge sensor. So really, you catch a large field of view. The difficulty sometimes, however, is that you have to somehow connect it to the microscope, and you need the right adapters. And this is sometimes where I found that some people have a problem with, yeah. But what I have got here is a DSLR camera because they really give the best image quality. Yeah. Yeah, so cross section of the spine. Let me quickly check if there's anything. Otherwise, what I'm going to do is, otherwise, I'm slowly going to call it a day again. Um, Imagine carefully hollowing out, putting LED inside. Yeah. Uh, yeah, these are the columns exactly. Yeah. So, folks, what I'm going to do is I'm going to call it a day today again. Okay. So just wanted to tell you, if you happen to have a 3D printer or so, I put into the link of this video, I put a download to the STL file in case you want to print it out. Okay. Yeah, just saying, I've been experimenting with those, and I think I'm going to keep on using them now that I have finally found at least, I'm not saying a great, but at least a workable solution of gluing them on here. Because before it, I used a regular nail polish, and it was not quite as solid as I hoped it to be. Okay, but with this gel, it's actually seems to be actually quite solid here. Okay. Yeah. Yeah, I think I'm going to I'm reading. Uh, but since I've subscribed here, I've always thought about buying a microscope. Yeah. Uh, Look into the custom G code. High temperature G will fuse with the glass. Okay. You can print the rings directly with no need to glue. So basically you're saying that that's an interesting one, that I should print the rings directly on the microscope slides. That's an interesting idea. Yeah, I think alignment is an issue here. Yeah. Okay, I'm gonna call it a day today. Yeah, thank you that you joined me again. I hope you found it interesting. And yeah, I'll think of another topic for next week. Okay. And yeah, see you around. Happy microbe hunting as always, and have a nice weekend. Bye bye.